Assalamu alaikum students. Today we start exercise 1.5. Graphs. We now learn the method to draw the graph of the explicit function like y is equal to f of x, where f of x is equal to a raised to power x, e raised to power x log x, or log x with base a and e. Graph of the exponential function a raised to power x, like we have place of a is 2 raised to power x. Now its table, we draw its values from calculator from -4 to +4, plotting the point and joining them with smooth curve as shown in the figure. We get the graph of y is equal to 2x. This is the graph of constant raised to power a variable always intersect y-axis at point 1, because when x is equal to 0 its value is 1, and from the graph the characteristics of the graph are observed as when if a is greater than 1 always positive, and ax increases as x increase, and ax is equal to 1 when x equal to 0, and ax tends to 0, then x tends to minus infinity. As we move to the negative side, the ax tends to 0. The approximate value of E is 2.718. We prove in the exercise 1.3. The graph of Ex has the same characteristics as the graph of the 2 raised to power x. Now we take its values from -3 to +3. We draw its values from calculator, plotting the point and joining them. Now the graph of e raised to power x, same like 2 raised to power x. It also intersects at the point 1 y-axis. Now the graph of log x, if the base is 10, now the values of y 10 raised to power y is greater than 0 and x is greater than 0. This means log greater than exists only when x is greater than 0. So its domain is positive real numbers. Log is undefined at negative values, also undefined at x equal to 0. Now it's stable from 0 to onward. And its graph like that. At x equal to 1 its value is 0, and after 1 and before 1 it's moved toward the negative side, and at 0 at infinity we move its graph toward the downward side of y-axis. Now this is ln of x graph. Now the same characteristics and the values like log x. We have both sign on the calculator of log and ln x on calculator. The graph of implicit function in which x and y are in one side or combined. First we move y to the one side, and this is the equation of circle with radius is 2 and center at origin. The equation does not exist at the values when we put in these values 3 and above values are above 2. So it's two values, negative and positive. We draw its table from -2 to +2, -2, -1, 1, 0, 1 and 2. Then plot these values. Here in last diagram we see that vertical line cut this graph in 2 points. Therefore this is not a function. Here its values and the table from 0, 1, square root 3 and 2, and -1, minus square root 3 and -2. You may avoid square root 3. We only take values from -2 to +2, -2, -1, 0, 1 and 2. Now here another implicit equation, and this is ellipse. Now we will put in this equation, we replace x and y by -x and y, or x and -y, or -x and -y. It is no change in the equation, therefore it is symmetric about origin. Symmetric means its graph around the origin is same. Now we make its shape like move y to one side and x to another, and its simplified form is and then we put the values from -2 to +2, because at 3 it gives undefined values. Now these are the parametric equations, and these are the parametric equations of parabola. X is equal to t square and y is equal to t, and y is equal to I think 2t. Now we take values of t from -2 to +2. First we put in x and then we put in the y. And then we draw the graph of x and y. It's shaped like this, and this shape is called parabola. Values are same, x equal to t square and y is equal to t. Now here we have a discontinuous function and piecewise form y is equal to x and x minus 1. Its values first function contain 0 to 1 and second 1 to 2. We draw its graph from 0 to 2 less than and equal to 1 we put in values x, and greater than 1 we put in the x minus 1. We put 0 in x, 0.5 in x, 0.8 in x, and 1 in x. And 1.5, 1.8 and 2 we put these values in x minus 1 and draw both the lines. Both are separate from each other, and this is the discontinuous function. This is also example of 1.4, and here we draw its graph in fraction, and its domain is except 3 all real numbers, because at 3 it gives 0 over 0 form. Now its table is this, from minus 3 to plus 3, but its main not contain value 3, so we put here in 4. Now let's draw its graph. At 3 we mark our open circle because it doesn't contain 3. Graph of equations. We solve then graphically. Cos x is equal to x. We have two functions, y is equal to x and y is equal to cos x. Y is equal to x is also linear, and it's also called identity function because its domain and range are same. Now from minus pi to pi we draw the values. Because y is equal to x is a straight line, we draw its only two values, 0 and 60 degree. No value of cos x. We draw both these graph. One is a straight line and one is a curve of cos x. Both the graph cut at only one point, and where they cut we vertically draw a line below on x-axis and find the point where they meet, and this is the solution set, and this is 0.73 where both these graphs intersect. We mark a point on x-axis at that point and find the solution set. Okay student, try to solve these examples, and in next lecture we solve its exercise questions. Jazakallah.